Any educated guess on how many are in the bag before we come up with a way to figure it out? Any guesses? Nothing at all? Even third period had a guess. 50-50. Thank you, Patrick. That's usually what most people say. 50-50. Okay, 10 red chips. All right. How are we going to find out? We're going to do a little trial right now. I'm going to pass the bag around. Every one of you are going to pick out a chip. We're going to record its color. You're going to put it back in, pass it to the next person. We're going to do this 30 times. So some of you get to pick more than once. And then you and I will figure out, well, what the heck do we do with all this information to predict how many red chips are in the bag? All right, so that's what I'm going to do first. We're going to pass it around. We're going to write down the color. All right, please don't look in the bag. Okay, everyone ready? Here we go. Red. So let's jot down one red here, however you want to jot it down. Let's keep going. What do you got there, Brienne? Okay, here we go. Red. Red. Looks like our prediction's off there, Patrick, a little bit, huh? And we have a black. Yeah, there we go, finally. Black. Red. Red. Pass it around. Black. Red. Shake it around there and let's get picking. Okay. Okay, let's go over here. Don't be creepy, just pick one out. Keep picking again, I don't care. We're only up to what, 20 right now? Okay, we got 10 more. Three more. Go ahead, that group, finish it up. Okay, here we go. Thank you, everyone. Appreciate all your participation. Now that we've picked all those, how can we make an educated guess now? Well, I think Patrick's 50-50 is out the window, right? I don't think there's going to be 10 in there. There may be. Who knows? All right, but now can we make an educated guess about how many reds are in there? Well, how many did we pick, guys? How many total chips did we pick? 30. How many reds came up out of the 30? How many? 23 reds out of 30, right? Which is about what as a percent? 23 out of 30. How much? About 70, what, 7%? So about 77%. How many total chips are in that bag? How many total chips are in the bag? 20 total chips, right? And we just found out, based on our random sample of 30, about 77% of them that came out to be red. Can we make an educated guess now? 20. What's 77% of 20? That'll be a nice educated guess. 20. About how many chips do we predict now? About how many? 15? Isn't that a better educated guess than me? And nothing's wrong with Patrick's 50-50. That was a fine guess. All right, but now that we did this, we're going to say there's about 15 in there. What if I went around again and again and again, and we kept doing this? How does that affect our guess? The more we do, remember from the probability unit, the more we do, the more accurate we are. All right, so the more samples, the closer we go, the closer we get to the actual number. So the closer we get to the actual number of red chips. You guys probably want to find out how many are actually in there, huh? How close we actually were. Patrick, just make sure I don't, influence this in any way. Black chip. Any more in there? Nope. How many red chips were in there? That's a mic drop right there. All right, 15. All right, and that was only with 30. The more we do, we'd probably get even more. I don't know, what was the decimal on your cat? 15 point something, I'm sure, right? That would just keep getting closer and closer to actually 15. Okay, not bad. All right, thank you guys. So we all see what I'm trying to point out here is the fact that the more we do, the closer we get, and we can make a little bit educated guess if we just went all around and did a sample ourselves. All right, okay, good deal. We had these two kids though, Tanya and Big Ron. They kind of did the similar thing with their mystery bag. So they did it 30 times, just like we did. They had, here we go, the first time around, they had 9 red chips. So I want to introduce you to something we'll be creating at the end of class today, and you'll be seeing through the rest of this unit. This right here, ladies and gentlemen, is called a dot plot. All right, a dot plot. So just so you can see how it works. The first time they picked 30, only 9 of them were red. So under 9, they put a dot. They did it again. They picked 30 more out. And the second time, only 12 were red chips. So they put a dot at 12. See how this dot plot works. How many times did they pick 30 chips? 50 times. So if you counted every dot, it'll add up to 50. Okay, so do you see what this is representing? Every time they picked 30, they counted how many reds and plotted how many reds they had. And they did that 50 times. All right? So answer some questions here for me. What's the most common number of red chips that they found? Most common number of red chips. Here we go. 13, most common number of red chips. 10. 10 red chips. Based on their dot plot, does this seem reasonable? That 10 was the most. Does that seem reasonable that 10 was the most? Be ready to back yourself up. Anyway. The fact that 10 was the most, does that seem reasonable based on the dots they plotted? What do you got for me? Here we go. 18, what do you got for me? What do you think, Matt? Reasonable? Why? It's close to all the other ones, right? That wouldn't make sense if I had all of them at 30. That wouldn't seem reasonable at all. But since 10 is right around all the other samples, yeah, it does seem reasonable. All right, so seems reasonable. Why does it seem reasonable? Because all the other samples are around 10. What chips never occurred? Here we go. What chips never occurred? Here we go. 3. Give me a number that never occurred. Which one? 20, right? Let's even shorten that a little bit because this looks like 15, 16, 17, 18, 19. And I don't want to list all these out. 19 to what never happened? 19 to 30. Every time they picked 30 chips, there was no 19 to 30 of them were red. Never. And also, you should give me another interval there that never happened. Here we go. 15. 0 to 6 never occurred. Not once. So knowing all these facts, looking at your dot plot right now, give me an interval that you think contains the number of red chips in this mystery bag. Okay, from what to what? What do you think? How many red chips do you think are in this mystery bag? Based on the dot plot, there is no one right answer, by the way. There's multiple right answers. Just want to hear what you have to say. 7, what do you think? Give me an interval where you think the number of red chips actually in that bag. 7 to 18. I'm fine with that. Okay? Maybe you think it's a little narrower. Give me another interval that it could be. 2. Fine. 10 to 14. Let's go one more. 11. All right. All those are correct. All right. Obviously, I wouldn't give me 0 to 30. Okay. Wouldn't give you 1 to 2. All right. Or 1 to 3. Those are all pretty good intervals where that may be how many red chips are in the bag. What my goal is today before you leave, find a correct interval that we are very confident in. All right. I'm going to show you how to find that interval that we're pretty confident in. All right. Last question. Number of red chips in the mystery bag could have come from a sample drawn from a bag that had 40% red chips. So what I'm saying, here's what I'm saying, because this is a tough one to understand. I'm putting a label on the bag. 40% red chips. Could these numbers come from this bag? 40% red chips. How many are in the bag? How many chips are in this bag? Not my bag, but this bag here. 30. Everyone, yes, there's 30 chips. If I am saying that there's 40% red chips, how many red chips should be in the bag? Figure it out right now. All right? I'm saying there's 40% red chips in the bag. And if there's 30 chips in the bag, how many red chips should be in there? 20? How many red chips should we don't have a 20. 18. How many red chips should be in here? 12 red chips. Should be. So based on what the numbers, look at your data plot above, look at your dot plot. Do you think this bag could be 40% red chips? A lot of people are shaking your head yes. Why? Tell me why. Why? 13. Tell me why. Most of the samples are around 12, right? So yes, most of the samples are around 12 red chips. All right, nice job. Okay, so how am I going to help you find this interval that we need? In all seriousness, some of you watch news, I hope. Some news. You ever see when they put the polls on the news? Like they went out and polled people, like a Siena poll, sometimes it's called, and they came back with the results, and it's always like at a percent. Does anybody ever see the little writing at the bottom where it says plus or minus? Anybody ever see that? Yes, no, maybe? No, not at all. You've never seen that. Maybe you just haven't paid attention to the little writing. Okay. All right, so all I did was cut and paste one. And it's just from the Republican primary last year. So these were the percents in favor of whatever candidate. Do you guys realize those aren't actual percent? Those aren't actual real facts. It's not like 4%, exactly 4% wanted Jeb Bush. No one's ever seen this at the bottom? Plus or minus a percent. This says plus or minus 4.9%. Here's what that means. Let me take Ted Cruz first here. 28%. That could be off 4.9% below or 4.9% above. Okay? 26% for Trump. Well, that could be off by 4.9% either way. That's what that is saying right here. Anybody know what that's called, by the way? We're going to find it now. Margin of error. Okay, that's called a margin of error. So it may be 4.9% above or below. I don't know. It's not exact, though. All right, so that's what that means on all these polls that you see on TV. How do I find that margin of error? You got it. Unfortunately, there are two formulas I'm going to have you know for the second half of this stats unit. One is called margin of error. And so we don't have to write margin of error. I'm going to always abbreviate it MOE. How do we find it? It's plus or minus 2, just like we saw in that poll before, plus or minus 2 times a familiar term we've seen from the previous part of this unit, standard deviation. So it's plus or minus 2 times the standard deviation. So negative 2 times the standard deviation, positive 2 times the standard deviation. Why do we need the margin of error? That's going to lead us to our interval I've been talking about. This interval that we are confident that the mean falls in. And we're going to call that interval our confidence interval. How do you find that interval? Are everyone ready? You take your mean plus or minus your margin of error. And that's the last formula. Let's find it, and then I want to talk to you about what it means. Here you go, another dot plot. I don't know, it doesn't tell me what it's representing, so. Everyone see I gave you the mean, and I gave you the standard deviation. Okay, margin of error. I'm gonna open it up to you guys. Here we go. Who has 3? 3? Okay, here we go, Isabel. Margin of error again, ready? Plus or minus, plus or minus 2 times, what's my standard deviation? 0.046, so go ahead, 2 times 0.046, let me know when you have it. Plus or minus 0.092. So there's my margin of error. Could be above 0.092 or below by 0.092. Here's the key to it all. Confidence interval. Okay, here we go. Who's got 16? 16? Brooke, ready? Confidence interval. The mean, what's the mean for this dot plot? 0.502 plus or minus, what was the margin of error? There we go. Now, everyone stop here because this is where people get confused. What's the plus or minus telling me to do? 0.502 plus 0.502 plus 0.092. And then you also have to do what? 0.502 minus. That gives you the interval, the high and the low point. So I'm going to ask somebody to do that for me. Here we go. 4. Who has 4? Okay, Ethan, here we go. 0.502 minus 0.092. Point 0.41. 2. 0.502 plus 0.092. 0.594. Let me do my best here. I'll let you guys just write it down here because I don't want you to just find numbers and memorize stuff. I want you to understand what it means. Here's what this confidence interval represents. This right here is just from a sample of a population. Everyone agree? That's not the entire population. We are confident. How confident? 95%. Anytime we find the confidence interval, it's always representative of 95% confidence. We are 95% confident that the mean for the population is somewhere between 0.41 and 0.594. All right? Don't say, oh, well, you already gave me the mean. That's the mean for the what? Sample I took. Based off of that, we're 95% confident that the mean for the population would fall between these two values. Where have I seen that 95% before? Where's that coming from? What is it? Within what? Oh, 2 standard deviations. All right, so we're relating it back to the curve. Okay? And, oh, this is Matt. Get ready for this one. Ready? The more I do here, all right, the more samples I do, what's going to happen to all these dots here? The more samples I do. The more samples I do, isn't it going to get more consistent? It's going to resemble our curve. The more I do. Okay? That's where all the 95% confidence, 2 standard deviations away from the mean. The more I do, the more it's going to represent the curve. Okay? Questions? You all right? All right. And that was just on number 1, right? You haven't even seen level 10 yet. All right. All right, another one. Lucas, don't even make me come over there, all right? Please, don't even. Come at me, kid, all right? Hope you like eating through a straw, all right? Okay, here we go. Same thing, margin of error. Here we go, 15. 15? Brian, here we go. Margin of error, plus or minus 2 times, what's my standard deviation? 0.019. What do you have? 0.038, thank you. That helps me find my confidence interval now, which is, here we go, help me out. 9, here we go back there. What's my mean? Okay, plus or minus, margin of error, 0.038. So go ahead, Braden. 0.5404 minus it, and then 0.4504 plus it. Yep, so there's my upper end. There you go. Again, I want to show you what it means. Now we actually have something. This represents the people who spend at least 15 hours of studying. We are now 95% confident that about anywhere from 41% to 48% of the population spend about 15 hours studying. Okay, we're about 95% confident that anywhere between 41% and 48% of the population we surveyed spends 15 hours studying. Are we okay finding this and then starting to figure out what it means? We all right? Okay? And I know people just started whining like crazy when they saw this next one. Oh boy, look at all the numbers. This question takes up the full page. Guys, I'm sorry, but that's what it's going to start happening now. A problem is going to take up a full page here now. All right, I apologize. All right, am I sorry? Not sorry, a little bit, but we got to get through it. 28 juniors. Ooh, great. Wanted to estimate the proportion of all juniors and seniors who have a part-time job. So each one surveyed 30 juniors and seniors and calculated the proportions. Hey, but I don't want to do anything yet. Here's what this problem is saying. Vinny, go out, find 30 sophomores, 30 seniors and juniors. Out of those 30, how many have part-time jobs? Vinny comes back. He's like, boss, 70% do. That's what that 0.7 is. Emma, go ahead, go out, survey 30 juniors and seniors. Come on back, tell me out of those 30, how many have part-time jobs? She comes back, 80% do. All right, that's what these numbers are representing. All right, they go out, survey 30 people by themselves, and come back and report what percent as a decimal have part-time jobs out of 30. Out of 30. Okay? Our first job, make a dot plot. Okay? It's what we've been doing, what we've been given all today, but I need to now make your own. So the first thing I need your help with is what should my numbers be on the bottom? Okay, so let's take a look at all those values. It goes from what's high and low here, so I can at least have some benchmarks. What's the highest and the lowest proportion they gave me up here? Anybody see the lowest? 0.4, I think, is the lowest, right? So it definitely should be 0.4. And what's the highest? Anything higher than 0.8? Nope. So let's make a class decision, because I don't think you want to go 0.41, 0.42, 0.43, 0.4, all the way up to 0.8. You can if you want. Anybody, what do we want to go by here? You're not going to be wrong. You can go by, if you want to go from 0.4 to 0.8 going by ones, that's fine. 0.41, 0.42, I'd rather not though. Any other suggestions? If we went by 0.4, 0.5, 0.6, that's kind of a little bit too spread out. I don't know where everything's going to be. You want to go by 0.05? Is that all right? Of course. All right. Or somebody would say no, but it's all right. So 0.45, 0.50, all the way up to 0.8. Go. Now we put our dots in the appropriate place. First dot, 0.7, so right above 0.7, we got a dot. We should have 28 total. Now, I know you guys are going each one. I don't know if it makes it quicker for you. Anybody remember the trick I showed you on your calculator that might be helpful right now? When you put all of them in a list and sort them? I don't know. That's up to you guys. It's up to you. All right, up to you. If you want to sort, you can just, so now if you sort them, you can literally just go left to right and put how many dots you need, but that's your call. Or if you want to go one by one as they're listed, go ahead. Just make sure you have 28 at the end. 28 at the end. Let's see if we match. Missing one. You guys are going to have to help me out when I'm done. I'm missing 2. What? 5 point? I'm missing 0.3, aren't I? That gives me 27. And point. Nope, I got 0.57. $6.3. Thank you, Megan. Nice. There we go. Yes. What, Meg? What? Then I'm going to have one more than I need, I think. Oh, Emma. And there's 2.63s. There we go. Obviously, I didn't use my sort, which I should have. How we doing now? How we looking? How's that compare? We good? Because I want to answer some questions. Okay. Do you think, based on our dot plot here, the proportion of all juniors and seniors at the school would be 0.7? What do you think? Do you think the true proportion could be 0.7 or not? It's a simple yes or no, and why here. 17, what do you think? Could it be 0.7? Yes. Why? Perfect. Yes. Because a majority of the samples are around 0.7. Do you think it could be 0.5? What about 0.5? 8? What do you think? Do you think it could be 0.5? Why not? There you go. Pretty easy, right? Based on what we plotted, and I don't think it's going to be 0.5 because look at where everything was. So no, because a majority of the samples are away from 0.5. And finally, suppose they did it now with 60 instead of 30 or 28. They did size of 60 now. How would the distribution or sample size of 60 differ from that of a sample size of 30? So instead of Vinny going out and getting 30 juniors and seniors, I'm telling them to go get 60 now. And everybody does that. How would that affect our dot plot here? What do you think would happen? What do you got, Ethan? More accurate. What's going to happen to my dot plot specifically? Because here we are right now, 30. What's going to happen to the dot plot when I go out and get 60? Guess what would happen if I got 120? More consistent. What's it going to start resembling? Yep, it's going to start resembling the curve. Yep. So with 60, scores will become more consistent. Proportions, not scores, excuse me. Proportions will become more consistent. And dot plot will start dot plot will look more like the, what do we call that curve? Anybody remember what we called it? Well, bell curve, more specific name. Began with an N, end in normal. Some people are still thinking about it. It's okay, no shame. They'll start looking like the normal curve the more samples we have. I'll tell you what, you guys did a pretty nice job with that today. I'm hoping some of it sunk in a little bit. All right, the more samples you have, the more it resembles the bell curve and consistent it gets. Try some of those problems on the other side there.